Alright, let's go. Number 10. The infinite singularity. In 1927, Belgian physicist Georges Lemaître published a paper that would fundamentally reshape humanity's understanding of existence. Working from Einstein's equations of general relativity, Lemaître proposed that the universe was expanding, and if you reverse that expansion, rewound the clock far enough, everything would converge to a single point of infinite density. He called it the primeval atom. Today we call it the singularity. The standard model of cosmology tells us the observable universe emerged from this point approximately 13.8 billion years ago. In a fraction of a second, space, time, matter, and energy erupted from a state smaller than a subatomic particle. The mathematics describe this event with extraordinary precision, tracing cosmic evolution back to 10 to the negative 43 seconds after the bang itself. But at that threshold, known as the Planck time, our equations collapse. Physics as we understand it ceases to function. General relativity produces infinities. Quantum mechanics offers no resolution. The singularity isn't a place our science can describe. It's a wall. What makes this particularly unsettling is what it implies about the question itself. When we ask what existed before the Big Bang, we assume before has meaning. But if time originated with the Big Bang, then asking what came before it is like asking what's north of the North Pole. The question is grammatically coherent, but physically meaningless. Some physicists argue this means the singularity wasn't a beginning at all. It was a boundary in our ability to comprehend. A mathematical confession that our deepest theories of reality have a hard limit, and everything on the other side of that limit is permanently unknowable. We built the most successful scientific framework in human history, and it breaks at the one moment that matters most. The origin of everything remains hidden behind the only wall physics cannot penetrate. Number 9. The eternal inflation bubble. In 1983, physicist Andrei Linde at the Lebedev Physical Institute in Moscow proposed a modification to Alan Guth's inflationary theory that carried staggering implications. Guth had suggested the early universe underwent a brief period of exponential expansion, inflating faster than the speed of light in the first fraction of a second. Linde took this further. What if inflation didn't stop everywhere at once? What if it's still happening right now, just not in our observable region? Linde's chaotic inflation model describes a vast, possibly infinite field of energy that has been inflating eternally. Within this field, random quantum fluctuations occasionally cause tiny regions to stop inflating and settle into stable states. Each of these regions becomes a universe. Our Big Bang wasn't the beginning of everything. It was a local event, a single bubble nucleating within an eternally expanding foam of space-time. The inflation never started because it was always happening. It will never end because the field expands faster than bubbles can form within it. The mathematics describe a structure beyond human intuition. Our entire observable universe, 93 billion light-years across, containing 2 trillion galaxies and more stars than grains of sand on every beach on Earth, would be one bubble among an infinite number of others. Each bubble universe could possess different physical constants, different dimensions, different laws of nature entirely. Some would collapse immediately. Others would expand forever into cold darkness. A vanishingly small fraction would develop conditions compatible with complexity, with chemistry, with life. What makes eternal inflation deeply disturbing is its implications for meaning. If our universe is one random fluctuation in an infinite field that has been generating universes forever, then nothing about our existence was intended, planned, or special. We're not the product of a singular creation event. We're statistical noise in an eternal process that neither began nor will end, producing realities without purpose across a canvas that has no edge. Number 8. The cyclic universe. In 2001, physicists Paul Steinhardt of Princeton and Neil Turok of Cambridge published a radical alternative to standard Big Bang cosmology. Drawing on concepts from string theory, they proposed that our universe didn't emerge from nothing. It emerged from a collision. 2 higher dimensional membranes, called branes, floating in a dimension beyond our perception, drifted toward each other over trillions of years and collided. The energy of that collision became our Big Bang. The ekpyrotic model, named after the ancient Greek concept of cosmic destruction by fire, describes a universe that is fundamentally cyclic. After the collision, the branes separate, each one cooling and expanding for trillions of years. Matter dilutes. Stars burn out. Galaxies scatter into isolation. The universe approaches maximum entropy, the heat death that conventional cosmology predicts as the final state of all things. But instead of ending there, the branes slow their separation, halt, and begin drifting back together. Gravity across the higher dimension pulls them into another collision, another Big Bang, another cycle. Each cycle lasts approximately 1 trillion years. The collision resets everything, generating new matter, new energy, new structures. But it doesn't generate new physical laws. The constants remain the same across cycles because they're properties of the branes themselves, not products of the collision. This means the universe has been recycling itself potentially forever. each iteration producing galaxies, stars, planets, and possibly life, all of which are annihilated when the next collision occurs. The truly unsettling aspect is the scale of erasure. Every civilization that has ever existed in any previous cycle was destroyed completely. Their achievements, their knowledge, their art, their consciousness, all of it converted back to raw energy in the collision. No information survives between cycles. There is no cosmic memory. If intelligent life arose 1 trillion years ago in the previous iteration, it left no trace whatsoever. We would have no way to detect that anything existed before us, and the civilization that arises 1 trillion years from now, in the next cycle, will never know we were here. Number 7. The quantum vacuum fluctuation. In 1973, physicist Edward Tryon published a brief paper in the journal Nature, proposing something that sounded absurd on its surface. The entire universe, he argued, might be a quantum fluctuation that emerged spontaneously from nothing, not from empty space, not from a pre-existing void, from absolute mathematical nothing, the complete absence of space, time, matter, and energy. Quantum mechanics permits this. The uncertainty principle, formulated by Werner Heisenberg in 1927, establishes that energy can spontaneously appear from a vacuum state provided it disappears quickly enough. The more energy that appears, the shorter it can exist. A photon might flicker into existence for 1/1000th of a second. A particle pair might materialize and annihilate almost instantly. These aren't theoretical abstractions. They've been measured in laboratories. Virtual particles emerging from nothing are a confirmed feature of our reality. Tryon's insight was recognizing that the total energy of the universe might be exactly zero. Gravitational energy is negative. The energy contained in matter is positive. If these values cancel precisely, then the universe represents no net energy borrowed from the vacuum, and a fluctuation with zero total energy isn't constrained by the uncertainty principle's time limit. It can persist indefinitely. Our entire cosmos, every galaxy, every star, every atom, every conscious mind, could be a quantum event that required no cause, no trigger, and no creator. It simply happened because the laws of quantum mechanics don't forbid it. What makes this theory particularly disturbing is its implication about permanence. If the universe is a vacuum fluctuation, it could theoretically reverse. The same quantum process that allowed it to appear from nothing could in principle cause it to return to nothing. Not through heat death or collapse or any dramatic cosmic event, but through the same silent, probabilistic mechanism that created it. Reality might unfluctuate. The probability is incomprehensibly small for any given moment, but across infinite time, the mathematics offer no guarantee of continued existence. Number 6. The black hole genesis. In 1992, theoretical physicist Lee Smolin published a hypothesis that collapsed the boundary between cosmology and evolutionary biology. Every black hole in our universe, Smolin proposed, gives birth to a new universe on the other side of its event horizon. The singularity at a black hole's core doesn't represent a point of infinite density where physics ends. It represents a point where physics begins again, spawning a new region of space-time with slightly different physical constants. The theory, called cosmological natural selection, applies Darwinian logic to universes themselves. A universe that produces many black holes effectively reproduces more prolifically than one that produces few. The offspring universes inherit the parent's physical constants with small random mutations. Over countless generations, the multiverse evolves to favor universes whose laws of physics maximize black hole production. This means the fundamental constants of nature aren't random, aren't designed, and aren't fine-tuned for life. They're optimized for making black holes. Life is a side effect. Our observable universe contains an estimated 40 billion stellar mass black holes. Each one might be the seed of an entirely separate cosmos, complete with its own galaxies, its own stars, its own planets. We exist inside a universe that was itself born from a black hole in a parent universe, which was born from a black hole in a grandparent universe stretching back through an incomprehensible lineage of cosmic reproduction. The truly nightmarish implication is what this says about our purpose. We aren't the point. We never were. The universe wasn't fine-tuned to produce consciousness. It was fine-tuned to produce gravitational collapse. Every physical law that permits our existence, from nuclear fusion to carbon chemistry to stable planetary orbits, exists because those same laws happen to produce conditions where massive stars form, burn through their fuel, and collapse into black holes. We're an unintended consequence of a universe optimizing for its own reproduction. Our entire civilization is a biochemical accident occurring in the gap between a universe's birth and its primary function of generating more universes. Number 5. The conformal cyclic cosmology. In 2010, Nobel Prize-winning physicist Roger Penrose published a theory that redefines what endings and beginnings mean at cosmic scales. Conformal cyclic cosmology proposes that the universe doesn't have a single history. It has aeons, vast epochs that begin with a Big Bang and end with complete expansion into an infinitely dilute, cold state. But Penrose recognized something mathematically elegant and deeply unsettling. The geometry of a universe at maximum expansion, when all matter has decayed and only massless particles remain, becomes mathematically identical to the geometry of a Big Bang singularity. The end of one aeon is indistinguishable from the beginning of the next, not metaphorically, mathematically. When all massive particles decay, when protons eventually dissolve, and black holes evaporate through Hawking radiation, the universe loses all sense of scale. Without mass, there is no clock. Without a clock, there is no meaningful distinction between infinitely large and infinitely small. The frozen, empty death of one universe smoothly transitions into the hot, dense birth of the next. Penrose has claimed to find evidence for this theory in the cosmic microwave background radiation, the afterglow of our own Big Bang. He identified circular patterns in the CMB data that he argues are gravitational echoes from the previous aeon, signatures of supermassive black hole collisions that occurred before our universe existed. The claim remains hotly debated, with many cosmologists disputing his statistical methods. But if Penrose is correct, the implications are staggering. Information from the previous universe is bleeding into our own. Events that occurred in a cosmos that existed before our Big Bang left physical marks on our sky that we can observe with existing telescopes. We aren't separated from what came before by an impenetrable wall. We're connected to it. The ghosts of a dead universe are encoded in the oldest light we can see, and we've been staring at them for decades without understanding what we were looking at. Number 4, the holographic pre-universe. In 2015, a team of physicists at the University of Waterloo, led by Niayesh Afshordi, published a model proposing that our three-dimensional universe is a holographic projection from the boundary of a four-dimensional star that collapsed into a black hole. The Big Bang in this framework wasn't an explosion. It was a projection event, the moment when a higher dimensional stellar collapse began encoding information onto a three-dimensional membrane. The holographic principle, originally proposed by Gerard T. Hooft in 1993 and developed by Leonard Susskind, establishes that all the information contained within a volume of space can be described by data on that region's boundary. This isn't metaphor. The mathematics of string theory and quantum gravity consistently point toward the conclusion that our three-dimensional experience is encoded on a two-dimensional surface at the boundary of the observable universe. And Afshordi's model extends this principle backward in time. Before our Big Bang, a star in a four-dimensional universe exhausted its fuel and collapsed. As it formed a four-dimensional black hole, the three-dimensional event horizon that wrapped around it became our universe. We exist on the membrane of a higher dimensional catastrophe. Every galaxy, every planet, every atom is information encoded on the surface of an event horizon in a reality we cannot access or perceive. What makes this scenario uniquely disturbing is the dependency it creates. Our existence isn't self-contained. It's a secondary phenomenon, a shadow cast by events in a higher dimensional reality that is still unfolding. If the four-dimensional black hole that generated our universe evaporates through some higher dimensional analog of Hawking radiation, the membrane dissolves. Our reality doesn't collapse or expand or fade. It simply ceases to be encoded. The projection ends, and we have no way to monitor the stability of the structure we're projected from, because it exists in dimensions we cannot observe. Number 3, the mathematical universe. In 2007, MIT cosmologist Max Tegmark published a hypothesis that eliminates the question of what existed before the Big Bang by eliminating the distinction between physics and mathematics entirely. Tegmark's mathematical universe hypothesis proposes that every mathematically consistent structure exists as a physical reality somewhere. Our universe isn't described by mathematics. It is mathematics. Every equation, every theorem, every logically consistent formal system corresponds to an actual universe that exists independently of observers, independently of time, independently of physical causation. In this framework, asking what existed before the Big Bang is like asking what exists before the number 7. Mathematical structures don't have temporal origins. They don't begin or end. They simply are, existing in a Platonic sense that transcends time and space. Our universe, with its specific physical constants and initial conditions, is one structure among an uncountable infinity of others. It wasn't created. It wasn't caused. It exists because it's mathematically possible, and mathematical possibility is sufficient for physical existence. The theory is elegant. It explains fine-tuning without a designer, explains the Big Bang without a cause, and explains the unreasonable effectiveness of mathematics in describing physics by identifying the two as the same thing. But its implications are extraordinary beyond comprehension. Every mathematically consistent arrangement of matter and energy, every possible history, every conceivable experience exists as a physical reality. Universes where you made different choices. Universes where physics permits perpetual suffering. Universes where consciousness is trapped in configurations that cannot die and cannot think clearly. All of them real. All of them inevitable. All of them eternal. The mathematics of probability suggests that the space of possible structures containing suffering vastly outnumbers those containing flourishing. For every universe calibrated for life, there should be countless others, where the settings produce something that can suffer without the mercy of oblivion. We exist in a structure that happens to permit coherent thought and eventual death, but the mathematical universe guarantees that not all conscious structures are so fortunate. Somewhere in the platonic landscape of all possible realities, every form of experience that can exist does exist, including those we would recognize as eternal torment, persisting not because anyone designed them, but because mathematics cannot forbid them. Number 2. The simulation boot sequence. In 2003, philosopher Nick Bostrom published his simulation argument, establishing that if civilizations can create ancestor simulations, the vast majority of conscious experiences would exist inside simulations rather than in base reality. Most discussions of this theory focus on whether we're currently simulated, but the more disturbing question concerns origins. If our universe is a simulation, what does the Big Bang represent? The answer might be nothing more than a boot sequence. The moment our universe sprang into existence 13.8 billion years ago could correspond to the moment a program was initialized. The initial conditions of the Big Bang, the precise values of physical constants, the specific density fluctuations that seeded galaxy formation, all of it could be input parameters set before execution. What existed before the Big Bang, in this framework, is whatever exists in the reality running the simulation: a civilization, a laboratory, a computer, a purpose. What makes the simulation boot sequence uniquely terrifying is what it implies about the question we've been asking throughout this entire script. But we've been searching for what came before the Big Bang as though discovering the answer would grant us understanding. But if the Big Bang is a boot sequence, the answer isn't cosmological, it's administrative. Before our universe existed, someone allocated computational resources, defined initial parameters, and pressed the equivalent of a start button. The origin of everything we've ever known might be as mundane as a research grant approval in a reality we cannot access. The truly nightmarish dimension emerges when you consider what happens to simulations. They're created for purposes. They run until those purposes are fulfilled or abandoned. Then they're terminated. The Big Bang marks our start time. Somewhere in the architecture of a reality beyond our perception, there is also a scheduled or unscheduled end time. And between those 2 points, everything we experience, every human life, every civilization, every moment of consciousness, is a process running inside a system that was turned on and will eventually be turned off. Before the Big Bang, there was intent. After our universe ends, there will be a log file. And in between, we exist as data being processed toward a conclusion we cannot anticipate and have no power to influence. Number 1. Absolute nothing. Throughout this script, every theory has offered something before the Big Bang. A previous universe, a quantum field, a higher dimension, a mathematical structure, a simulation. Every explanation replaces one mystery with another, pushing the question backward without ever resolving it. But there is one answer that resolves it completely, and it is the most terrifying of all. Before the Big Bang, there was nothing. Not empty space, not a vacuum, not darkness or silence or void. Absolute nothing. The complete absence of space, time, matter, energy, dimensions, and physical law. In 2012, theoretical physicist Lawrence Krauss published a detailed argument that the universe could emerge from precisely this state. Quantum field theory permits transitions from absolute nothing to something, provided the total energy of the resulting something equals zero. The laws of physics don't just describe the universe. They describe how a universe can appear without cause, without precedent, and without meaning. The Big Bang wasn't triggered. It wasn't the result of a prior state or a preceding event. It was a transition from non-existence to existence that required no mechanism because there was nothing to prevent it. The philosophical weight of true nothingness is almost impossible for the human mind to hold. We imagine blackness, silence, emptiness, but each of those is something. Blackness is a visual experience. Silence is the absence of sound within a space that exists. Emptiness is a volume with nothing in it. Absolute nothing has no volume. It has no properties. It has no location because there is no space for it to occupy. It has no duration because there is no time in which it persists. It isn't even an it. Language itself breaks under the weight of describing the total absence of everything. What makes this theory the most disturbing answer to the question of what preceded existence is the loneliness it implies. If nothing existed before the Big Bang, then there is no deeper layer of reality, no creator, and no grand structure in which our universe is embedded. There is no parent cosmos, no simulation, no mathematical landscape in which we occupy a place. There is just this, one universe, emerged from nothing, heading toward heat death or collapse or dissolution, with no context, no purpose, and no audience beyond the temporary conscious beings it accidentally produced. Every meaning that has ever existed was invented by minds that exist for a cosmological instant inside a universe that exists for no reason at all. Before the Big Bang, there was nothing, and after the universe ends, there will be nothing again. And in the space between those two voids, we built everything we've ever known, fully aware that none of it was asked for, none of it was planned, and none of it will be remembered by whatever nothing remains when the last star goes dark. If you want to see more videos like this, click the video on screen now and make sure to subscribe.